Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott.
And in studio with us we have Sophia. Sophia, if somebody needed to get a hold of us, what would they need to do?
For math homework help, call in Bakersfield 636-4357. Toll free 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net and on social media and Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. So, Sophia, where do you go to school and what grade are you in?
I'm in 5th grade and I go to Ronald Reagan.
And have you been a patriot for a long time?
Yes, ever since kindergarten.
Ever since kindergarten. All right. Well, I hear that it might be possible for kids to go back to school at some point this spring. Are you excited about that?
Kind of.
Kind of.
Yeah, because I don't want to go to school and wear masks and have social distancing.
Okay, yeah. So going to school and wearing a mask is kind of be like, you know, so there
All
are some.
day. That's like so much. I don't want to.
Okay. Well, what do you most look forward to? Because I know you don't look forward to wearing masks and social distancing, but what do you most look forward to if you have the opportunity to go back to school?
Going to meet my friends again and seeing my teachers.
There you go. So, well, that's a big thing because, I mean, if you have a new teacher that you've never seen on campus before, you've never actually met that teacher other than through a screen, right?
Yeah.
And then you're able to see your friends and do some activities like that and stuff. So, very good. All right. Well, you know what? You ready to do some math work today?
Mm-hmm.
Good. I'm glad you are because you're going to do some science activities also. So I hope you're ready for that. But before we get to any of that, let's first take a look at today's Math in the News. All right, today's Math in the News. This was actually a problem that was on the internet over the weekend, and I figured, it's got some math, numbers, letters, and a question mark in there. So I figured, let's go ahead and take a look at this and where this is going. So, A plus A plus A is equal to 39. B plus B minus A is 25. 6 plus C plus B is 50. So they want to know what A plus B plus C is. So, Sophia, do you have an idea on how we can solve this? Where do we start? Do you have an idea?
Well, to find out what A is equal to, you'd have to do 39 divided by 3 because it's 3 A's.
Perfect.
Which is 13.
Excellent. All right, so it's 13. Now, I don't know if you can write on that board right now while it's up there, but if you want to, try. Maybe just put A equals 13 off on the side someplace. There you go. So we know A is 13. So you can just stand right there if you want, because you're going to write some more stuff up on the board. So how would we solve for B plus B minus A equals 25?
Well, since we know A is 13, we need to subtract 25 minus 13 and then divide by 2, because it's 2 B's. So 35 minus 13, which is 12. 12 divided by 2, which is 6. So B is equal to 6.
Okay, so let's check that real quick. I like the way you're thinking. You're definitely in problem-solving mode, I can tell. You've done stuff like this before. This is great. So let's check to make sure that your answer makes sense, right? So just in your head, real quick, you said B is 6, right?
Yes.
So 6 plus 6 is 12.
12.
Is 12 minus 13 25?
No.
Uh-oh. So one little thing we need to change in your logic. And your logic was good, but you said 25 minus 13, right? This says minus over here, but when you bring that over to this side, you have to change the sign. So instead of minus, what would you do?
Addition.
There you go. So what's 25 plus 13?
25 plus 13, which is 38.
38, and then you can divide by 2.
And
Then your
divide
rationale
by
will
2.
work.
So 38 divided by 2, which is...
And if you need to do it on the side, you've got room over on the side. You can work it out.
We got some serious mental math going on here today. I'm impressed.
You can go over by the 50 and the question mark over there, and you can write it down over there if you'd like.
Well, 25 plus 13.
So you're going to do 38
25 plus 13, good. And that's
divided by
38.
2.
So you were right.
38 divided by 2, which is... This is 1, this is 2, 18.
Oh, you're doing great. There it is, 19. So we have 2 of the letters.
So go back over to your left, and we'll put B is 19.
B is 19.
So now how are you going to figure out the next equation where we have C?
Well, since B is 19, 50 plus 19?
So right here is 19, right?
Yeah,
Good.
and then we don't know what
And
C
so
is.
over
and
here, this said minus, and you added on the other side, right?
Yeah. So
Now
we're
it says
subtracting.
plus, so what will you do on this side over here?
Subtract.
Gotcha, there you go. So 50
Minus.
minus 19. You
19.
want to do the mental math, or you want to work it out?
I want to do mental.
Go
math.
ahead, you can work it out right there on the board. She says, I want to make sure I'm right. You can do it on the board there, that's all right.
31.
31, that's it, good job.
Now we also have a 6 over there.
Oh,
Yeah, we do have to worry about that part too, huh?
Uh,
So now, really, what we have, if we had to write it out again, what we really have left is 6 plus C equals
31.
31. So what would you do on that?
Divide 31 by 2.
That's definitely one option that we have. We could always do that and check. But let's again look and see what is happening there. What is the sign on the 6? Is it a positive or a negative 6?
Positive.
It is. And so what's the opposite of positive?
Negative.
That's it. You got it. So this is a positive 6. And if you had to move it to the other side of the equal sign, right? I always think of this like a little squiggly line. If you have to move it to the other side, you have to do the opposite of what it says. Right? Because we take that
So-
here. And so we're going to subtract it.
Okay.
This is some fun algebra. You're doing some algebra already. What is 31 minus 6?
31 minus 6 is 27.
20, almost?
Oh, 25.
25. You want to check it real quick?
Yeah, sure.
6 plus 25. Yeah, I'm glad you did that. That's good. That's it. So we'll check the whole thing. Ready? 6 plus 25 plus 19.
6 plus 25 plus 9.
And then we'll hope that that's 50, right?
6 plus 25
Mm-hmm.
plus 19.
Yeah.
5 plus 6 is 11. 11 plus 9 is 20.
20. Good for you. I'm glad you're saying that out loud, too, so we kind of know what's going on in your head.
1 plus 2, wait, 2 plus 2, which is 4, plus 1 is 5.
1 is 5. That's it. So that worked out great. So now we have a value for A and B and
And C.
C. You think we can finally figure out what this puzzle is going to be?
Probably.
Probably. What is the value of A?
A is 13.
Okay, let's
And
see if we
then-
can write that down over there. I don't even know where I am. So over there on the A part there, right above the A, right 13, the big black A,
Oh,
and right above the B, what's B?
19.
19, and right above the C,
What was C again?
what was C? Way over here.
6, I think.
Way over here.
Oh, yeah, it's 6. No, 25.
25. And now all you gotta do is add them all up and you'll figure out what the solution is.
13 and 19. I'm just going to add those and then add the other one. It's 12, 32.
32, good.
32 plus 25, which is 57.
57.
So 57 is your final answer.
Yeah.
Feeling good
All
about
right,
that?
let's take a look.
Yeah.
Hey!
57 is the correct answer. Nicely done.
Nice work.
All right, you feeling pretty good?
Yeah.
Good, because that was the first of many to come. So here we go, Hotshot. Let's try this one.
Uh-oh, we got more.
Let me tell you, because this led into a couple. There are 3 of them all together to make up today's Math in the News. So this
I
is
know the answer.
number 2,
Okay.
which is why we have all the 2s.
I know the answer.
She's feeling
know the
awfully
answer.
confident already.
What is it?
0.
Uh-oh.
0?
No, it's 2.
2. Well, which one is it, 0 or 2?
2.
You're sure?
Yeah.
All right, Hotshot. Ooh, it's
Oh,
22.
it's 22.
What
the
happened?
heck?
Let's go back and take a look.
Let's go take a look. So, Sophia, do you know a little bit about the order of operations?
Yes.
Okay, so what is the first thing you do in the order of operations?
Multiply. Well, parentheses.
Parentheses. We don't have any parentheses here.
And then exponents.
Exponents. We don't have any exponents here. What's next?
Multiplication.
Multiply. So what's the very first thing you would do in this problem?
Multiply 2 times 0.
That's it. What is 2 times 0?
0.
And so these two right here, oops.
Oh, because I think you're hitting
Sorry
the
about
X
that.
button there.
So 2 times 0 that you have there at the bottom, right, would just be 0. So the 2 and the 0 would be 0, but all the other 2's would still be
2,
there,
4,
right?
6, 8, 10, 12, 14, 16, 18, 20, 22.
So you can verify that it actually is 22. But you
Yeah.
can see why people will get it wrong.
Yeah.
Yeah, because you look at that and go, oh, it's a multiply times 0.
Times 0,
I know the
zero
answer right
together.
away without working.
Right, and Sophia, you do what many kids do. They see that 2 times 0 and they go, I know order of operations. That's 0 plus 2, it's 2.
Yep.
All right?
Yep. Or 0.
But we know it's 22, and
22.
that New York Yankee number right there, many great
saw that
players have worn that
pinstripes.
one. Got to wear the pinstripes. All right, young lady, here we go. Can you find the missing number? So explain to Scott and I what you're thinking about as you're looking at this.
Well, I wanted to see whether if I add them and they make the same number,
Okay.
if that would do it, but I don't know. So I'm going to try the sides like this.
Okay.
So 1 plus 7, which is 8, 8 plus 9 is 17. And then, no, it's 9. And
So
then,
you were thinking about going down the side of the
yeah. going down.
triangle there, huh?
Yeah.
And if you went down this side too? Don't
that
quite
won't
seem to have a
work.
pattern though. Keep looking for patterns. There's definitely a pattern here. What else were you thinking?
When I first saw it, I was looking at 9, 2, 8, 1, 7, 6, 7,
Okay.
1, 1.
So you went down the side of the triangle, right?
Yeah.
And that didn't work. And then you thought maybe we can go along the base, right? 9, 2, 8, 1,
But,
or maybe 7, 6, 7.
but it doesn't.
Starting
Quite
at the
there.
base is a
What else?
better way to start, I would say.
Yeah. What else do you think you could do there? What if you just look at the first 2 numbers? What do you want to do with 9 and 2? What could you do? You could add them together, right? What's 9 plus 2?
11.
11. I don't see an 11. Well, you kind of have to jump up there, but really it looks like it's just a 1 and a 1.
Yeah.
What else could you do with 9 and 2?
You can multiply them.
You could? What would you get?
18.
18. Looks like maybe you have 18, but it's swapped around over there. Not quite. What else can you do with 9 and 2?
Well, you can't divide them. You could subtract
You could subtract them. What's 9 minus 2?
7.
Uh-oh.
There's a 7.
Let's see if we have a pattern here. We're going to subtract these two. What's 8 minus 2?
8 minus 2 is 4. Or 6.
6. There you go. Last one. What is 8
8
minus 1?
which is 7.
7. Let's see if the pattern still continues. What's 7 minus 6?
1.
1. What's
7
this
minus
7 minus 6?
1.
1. So what do you think goes in the question mark?
0.
Aha.
it's
Would you
one.
bet money
Let's
on it?
take a look. She's going to say 0. Now, you're sure because 0 is not really, I mean, are you sure 0 is an answer we can put in there?
And it didn't work
Yeah.
last time. Are you sure?
Why do you think, you sure 0?
Yeah.
Hey!
0 is the correct answer. All
Well
right.
done.
And the reason I wanted you to do that one is because a lot of kids, they get 0 and they go, well, 0 is not really a number. I don't think we can do 0. You know. So that is today's Math in the News. So one little problem that we saw in there, and we saw a couple of other problems that went right along with that. So that's a nice little warm-up for you, huh?
Yeah.
You feeling good? Mm-hmm. All right, good, because now we're going to get to your homework. All right? Let's take a look at the first problem. It says, Barry wants to make a drawing that is 1/4 the size of the original. If a tree in the original drawing is 14 inches tall and 5 inches wide, what will be the length and width of the tree in Barry's drawing? So we're going to make it 1/4 of the size that it is, which is 14 inches tall and 5 inches wide. So do you have an idea? You and Scott go ahead and talk about that and how you want to approach that problem.
Well, Since it says that we want the length of and width of the tree in Barry's drawing, and is 1/4 of 14 and 14 inches tall and 5 inches wide.
So let's explain real quick. I want you to answer this question. And I can tell you're already thinking in your head, but is our final answer, just so that we have an idea what's going to happen, is the final answer going to be big, like for the height, for how tall it is it going to be bigger than 14, or is the final answer going to be smaller than 14?
Smaller, because
Smaller.
it's 1/4 of 14.
Aha, 1/4 of, right? So we're making all these numbers smaller. So at least we know that part for sure. So we got to make sure that when we find an answer, we're going to make it smaller. So what does that word of mean to you?
Like divided or subtracted.
It kind of makes things smaller, right?
Yeah.
The word of in math actually means multiply. But the reason that things are going to be smaller, just like you're saying, is because we're multiplying by a fraction, and that will make things smaller, right? All right, let's see if we can do a little math here. What kind of things you want to multiply together?
We can make 1/4.
1/4.
Times 14 over 1.
There you go, good. And you make 14 into a fraction as well. Good, there you go.
Which is equal to 14 over 4, which could be simplified to 3 2/4, which could be simplified into 3 1/2.
Wow, you did that quickly. Tell me a little bit about how you got from 14 over 4 to 3 2/4.
Well, if you divide 14 divided by 4,
okay, gotcha.
you get 3, which is 12. You get 2, and then you make this your denominator, so it becomes 2/4.
The remainder is on the
and
numerator?
2/4, if
Yeah.
you simplify it, becomes half.
I like that. That's a great way to do it. So you're thinking that the new height of the tree is going to be 3 1/2 what?
Inches.
Inches. Okay, can we make that? You can write out the word inches, or you saw on the original part, I put the little quote sign. Yeah, there you go. Okay, what about the next part?
1/4 times 5 over 1.
Let's do it. There's your 1/4. Good. And you can step right over there. You don't have to reach. There you go.
Just 1.
5 over 4.
1/4.
1 1/4. Tell me how you got that one.
Well, 5/4, you could put 4 over 4 in once, not twice. So it's 1 1/4, because there's a remainder of 1.
1 remainder of 1. Okay, gotcha. So we have 3 1/2 inches tall. What about 1 1/4 what?
Inches wide.
Inches wide. And that would be, let's just make sure that from the beginning, the question I asked you, are both of those numbers smaller than the original number?
Yes.
Are they less than half of the original number? Because 1/4 is less than half, right?
Yeah.
Are they both less than half? Is 3 1/2 less than half of 14?
Yeah.
Yeah, it is. Is 1 1/4 less than half of 5?
Yes.
So at least the answers make sense, right?
Yeah.
And sometimes we can catch our mistakes. If we look at an answer we have and it doesn't make any sense, we can fix it before we even find out what the real answer is.
And
Great
what you were
work.
doing right there is nice to do, because it will give her an idea of how to do this mentally.
Right.
Because if you have 14 inches and you want 1/4 of it, well, if you think about half of 14 is what?
Half of 14 is 7.
Is 7, right? And you want half of that to make the 4th. So what's half of 7?
Half of 7 is 3 1/2.
And that's what
Hey,
you got,
look
right?
at
So that way you can think
So
about
it's
it
1/4.
without having to
1/4.
actually work it all out. Once
Yeah.
you get good at it and can start working on that skill. Nicely done. Let's go on to your next homework problem. This one we've got is number 5. So you guys
go.
can erase that board. There we go. A blueprint is a scale drawing of a building. The dimensions of the blueprint for Patricia's dollhouse are 1/4 of the actual dollhouse. So we have 1/4 again. The floor has an area of 864 square inches. That is the area of the floor.
So the whole entire thing.
Right, for the whole dollhouse. If the width of the dollhouse is 2/3 the length,
Then
what are the dimensions of the floor? So we'll need length and width. So the width is 2/3 the length, and the whole thing is 864 square inches.
We got a little thinking to do here, huh? You said blueprint, so I went blue for you. So at least we got that part going on, but I don't know about the rest of this math. Where in the heck do you want to start on this one?
2/3 times 864 over 1.
Wow. Kind of crazy, huh? Now remember this number here, this 864, is actually the whole entire area, right?
Yeah.
Okay.
So
So how do you find the area of a floor?
length times width.
There you go. So at least we know that this should be at some point, somewhere along the line, this should be length times width, right? Mm-hmm. Ooh, that's supposed to be a W. There you go. So if we knew what L and W were, then we could definitely plug them in there, right?
Mm-hmm.
Do we know what L is?
No.
We don't know what L is. Do we know what W is?
Not necessarily.
Look over here. It says W equals something, so we must know what it is,
2/3.
right? What does it equal?
It's 2/3 the length.
That's it. So we have 2/3 of L. So really we have an equation here with only one letter. And if you have an equation with one letter, we love that to happen in math because you can always figure out what that one letter is. This answer is going to be 864. So the key is to figure out what are we going to do with all this stuff over here. That's kind of a wild deal, huh? Yeah. Any ideas about that? L times 2/3 of L. Well, what is the number that's right here before the L, even though we don't see it? What number would you put there?
Something that can go to, so 2/3 could go into.
Well, how about this? How many L's do you see there? Don't look at the 2/3 part, but how many L's do you see here in the beginning of the equation?
1.
Just one. So we have 1 L
2.
times 2/3 L, right? That's really what we have.
Yeah.
Yeah.
So 1 over 1.
Yeah, so we're kind of doing all this math, right? Yeah, so we have 1 times L times 2/3
L.
times L. Oh my gosh, that's a lot of work. Wow.
It's a lot of L's.
What else do you want to do with that? How about what's 1 times 2/3?
1 times 2/3 is 2/3.
2/3, all right. So we'll just kind of not worry about the 1 anymore. At least we got that part done. And this is still 864. You were talking about L times L. What is L times L? Do you know?
L squared.
It is L squared. Gosh, really well done. It's L to the second power. That's it. And we still have this crazy 2/3 over here, right? So far, you are doing a wonderful job. And we haven't touched the other side yet. Now remember on the very beginning of the show, this is really going to work out well, because when you had a plus number on one side and you had to move it to the other side, you had to do the opposite, right? Yeah, so if it was a plus number on one side, it had to become a minus number on the other side. What do we see here? What is this little dot here that I've written? What does that mean in math?
Multiplicate.
That's right. So if you want to move this 2/3 to the other side,
2/3 times L.
what's the opposite of times though?
Divided by.
It's divided by, that's right. So now, here's the problem I want you to work out. 864
divided
divided by
by 2/3.
2/3. Can you figure what that is? That's an interesting problem.
Now, have you divided fractions yet?
Have you divided fractions before, Sophia?
No.
Oh,
All right, so
that's
that's
a
where we're going
challenge.
to, okay. So let's go over that first before she gets too far.
Okay, so ready? Right over here, we'll do a real quick problem. Watch this. 1/2 divided by 2/3. Okay, let me show you how to do this problem. This problem becomes a multiplication problem. You keep the same fraction at the beginning.
Oh yeah. Stay, change, flip.
That's right. Stay, change, flip. I like what you did there. And so let's do the same thing over here. Can you make 864 into a fraction? That would stay. Good.
Or 1 and then.
And I'm going to give you a little bit more room so you can kind of see what you're doing there. There you go.
So it could become.
So let's rewrite it.
864 over 1 times.
There's your change.
3 over 2.
Oh, good for you. And there's the flip.
This is
And to help you out with time, instead of multiplying it longhand, 864 times 3 is 2,592.
Woo!
2,590.
Let's save this little time. What's the last part we have to do about that, though?
2592 divided by 2 because
And for the sake of time,
Okay.
that is 1,296.
1,296.
296. Now, the last part is, unfortunately, sometimes math problems get a little bit long, but that's why we love them. We still have this L squared. What the heck? How do you make that thing go away? Oh my gosh. 1296 equals L squared. So some number times itself is going to be 1,296. Ready in your head? Do it.
Do what?
36. Sophia.
Divide it by
36.
2. Okay, 36.
You're a genius. Oh my gosh, how did you do that? That's amazing. 36 is the new length.
So
And here's definitely a problem you could do if you wanted to find out the width, right?
the width is
This is definitely a problem that you could do because I've seen you do fractions. 2/3 of 36.
2/3 of 36.
Let's see if you can do that one.
Which is equal to 2.
Do you know how to cross cancel?
Yeah.
Oh, here she goes. Yeah, there you go.
Wait, what?
Cross cancel the 3.
Which becomes
That becomes a 1, and that becomes.
3, 1, 12.
Oh, she is a smarty. I like it. 2 times 12.
24
Well
over
done.
1, which is equal to 24.
So the new length is 36 inches, and the new width is 24 inches.
24 inches. Okay.
Man, that was fun.
That was a good problem right
Yep,
there.
that was a
Nicely
good one.
done.
No problem.
And for your efforts today, Sophia, you've got a meal courtesy of our friends at Grillenberger. So congratulations on that. We hope you have an opportunity to go over, say hi to Lydia and everybody, and enjoy a meal. We do have phone tutors available until 5:30 this afternoon, as we do most Tuesdays and Wednesdays throughout the regular school year. We'll be back with more right after this.
Today we're at the Henry C. Garnett Water Purification Plant in Bakersfield, and today I've got a couple of partners with me.
I'm John Soper from Garces Memorial High School.
I'm Olivia Belda from Centennial High School, and John and I are part of the Dream Builders and Forward Dimension program at the Jim Berg Forward Education Foundation.
And it is time now to go with the flow on this edition of Do the Science. Well, here at the Water Purification Plant, we might as well start at the beginning with the head man himself. Dave Beard, how are you today?
Good. How are you?
Good, nice to see you. What is your official title with the Purification Plant?
I am Improvement District Number 4 Manager. Improvement District Number 4 has a number of functions, but our primary mission with the district is to provide a supplemental water supply for the urban Bakersfield area. And one of the primary ways we do that is to take untreated surface water, or we'll call it raw water, and bring it to the Henry C. Garnett Water Purification Plant for treatment and delivery as drinking water to customers within the urban Bakersfield area.
Okay.
Dave, I'm interested. How'd you get into that field?
So for undergrad, I graduated with a degree in economics, and then I went to graduate school and got a degree in environmental science and management. But that environmental science degree also had a specialization in water resources management, and then the Kern County Water Agency had an opening with Improvement District Number 4, and that's how I got here.
Well, we're at the very beginning of everything, and we know how you got started in your role here. This is the equalization pond.
Yes.
What is going on here?
Okay. Well, behind us is the temperature equalization pond, and it does have a few functions. One of the primary functions is to allow an initial settling. So when we do bring the untreated or the raw water in, if there's any large particles that'll just settle out via gravity, that's one of the functions of that. We like to try to keep the temperature of the water constant or equalized. So if we do switch sources, that'll prevent potentially damage to your facilities or infrastructure. We are unique here where we can treat water from 4 different sources. We are a state water project contractor, so if we are treating that water actually comes from the Sacramento and San Joaquin Delta. We also are able to exchange water with Kern River interests and treat Kern River water. We can treat groundwater, and we can also treat water off Central Valley Project Frank Kern Division.
So we've got a lot of spots that the water comes from. A beautiful spot you've got out here, a lovely place to work, tranquil. You must just like to come and hang out every once in a while.
Exactly. But that is also one of the things we have to look out for is people do want to come and hang out at the pond This is actually part of our water treatment process, so we can't really have any unauthorized folks kind of hanging out or fishing or even swimming in the pond.
Well, we won't hang out too long.
Yeah, exactly.
We know where the water comes from. Let's go check out where it's going to.
Okay, let's go.
Well, Dave, we saw where the water came from, and there's a lovely buzz in the air, so we know things are working right now. Right now, we're in the raw water pump station. What exactly is going on in back of us?
Well, with the raw water pump station, we need to have a way to physically move the water from the temperature equalization pond to the purification plant. And so this is the facility that was constructed to do that.
And how many pumps do you have in here?
Presently, we have 4 pumps. Most cases, they don't all operate at once, so it does provide us a nice measure of redundancy should we have one go down due to mechanical or electrical issues. But typically, you have 2, maybe 3 operating at one time.
Dave, we have a lot of water out there, a lot of pumps in here. Exactly how much water is going through this facility?
Well, that is a good question. It really depends on the time of year that you're in. If you're in the winter time, kind of the cooler months, you'll see flows as low as 14 million gallons per day. But then if you get into the summer or the higher demand, the peak months, you can see flows up to 80 to 90 million gallons per day.
Put that in perspective for us. That's a lot of water, a lot of gallons. Exactly how do people in the industry measure how much water is transferred and how much we get in our homes?
It is. We do speak a lot about million gallons of water here, but then we also speak about water in terms of acre feet. 1 acre foot is the equivalent of almost 326,000 gallons, and that typically is enough to serve a family in the Central Valley for a year. If you're more of a visual person instead of a numbers person, you visualize a football field with water on top of it that is 1 foot deep, and that's as much water as a typical household uses in a year.
Sure.
So we know how much water is being pumped through here, and this is all of the water from the equalization pond.
Yes.
Now that you've got the water in here, how many different places will it go from here?
Well, from here, it will go to the purification plant for treatment. There's a number of treatment steps that we go through at the plant. But then from there, after the water's been treated to drinking water standards, it'll go to one of 4 customers of the Kern County Water Agency Improvement District number 4. And that will actually serve most portions of urban Bakersfield, to the east, to the north, and to the northwest.
All right, so you're covering a lot of area, and let's go find out now where it's being chemically treated.
Sounds good.
All right, let's go.
And for a molecule of water to start here at the flash mix and get through the treatment plant, at the low flows, it would take about 5 hours. And at the higher flows, about 50 million gallons a day, it would only take about 2 hours.
We're always doing something. Do the math, do the science, do the water. Time now for today's museum moment. All right, we are fortunate once again to have for our museum moment Dave Hanley from Buena Vista Museum. Good afternoon, Dave.
Hey, good afternoon. I love rates.
Oh, you know what? I think that's exactly what you're going to talk about today. You've got 5th grader Sophia from Reagan, so take it away, Dave.
All right, thank you. I love rates and ratios and percentages and probabilities and all the purrs. What makes a purr?
A cat.
I love it. Yeah, my cat does. Yeah, she does. And then she licks me on the nose. Okay. So, see, this is a 15 per 50. Mm-hmm. And this is a 25 per 1 hour. That's how fast I'm going, right? Mm-hmm. Those are all rates, ratios, percentages, numbers, so forth. Okay? And they're a lot of fun. A lot of fun. Okay, here we go. So this here, okay, good, I got that out. This is my siphon. You know what, I'm gonna hold it up and we're gonna do it onto the table. Okay, so I want you to reach up and pull that out, and we're going to count and see how fast it goes. Let go, let go, let go, let go, let go. Yeah, there you go. Oh. Okay, give it a pull. Let go, let go. Yeah. Okay, 1, 1,000, 2, 2,000, 3, 3,000, 4, 4,000, 5, 5,000, 6, 6,000, 7. Oh. Come on now. Okay. Okay, we're going to have to do a rerun on that one. That's too bad. Okay. We got to put it back in the same way. This is a mechanical siphon, basically. Like you can get water out of an aquarium. Right, exactly. Okay, so this one, now, if I buy these from a science supply catalog, they're $20 for 45 feet of beads. But if I go to the dollar store and I put them together, that's about $4 or $5 worth.
Yeah.
Okay, so I save money. I like making my things out of junk.
Maybe this time, Dave, try it like you did on the edge of the table going onto the floor.
That sounds like a plan. Okay, here we go. Let's go. Are you ready? Count with me. Are you ready?
Yeah.
1, 1,000, 2, 2,000, 3, 3,000, 4, 4,000, 5, 5,000, 6, 6,000, 7, 7,000. Okay, we got on 7 seconds. All right, so 7 seconds. Okay, the first time we did it, we got about 6 seconds.
Yeah.
Okay, so we've got 45 feet of beads, and I've already counted it up. There are 20 feet of beads, or 20 beads per foot.
Per foot.
So we've got 20 beads per foot, right? Mm-hmm. Times 45 feet, right? And it took 6 seconds. Okay, so we can figure out how many beads per second.
Well, since it was 6 seconds, and so multiply and make it 45 over 1.
45 over 1, that's correct.
Times 20 over 1, which is 20. So 45 times 20, which is 900.
Uh-huh.
That's what you do. So 900, and then divide it by 6.
Seconds. And that means that we could go, we could do,
200.
There's 2 3s and there's 3 3s, right?
Yeah.
You were just doing that earlier. So it's 3 per 2, so it's 300, so it's 150 beads per second.
Yeah.
All right. Isn't that great? Isn't that great? All right, good. Yeah, all right. So that's per, right? Mm-hmm. That's the rate of flow. Okay, so that's fun. Now, I like about solar panels, and I like about electricity and all the environmental stuff. Mm-hmm. I also like listening to rock and roll. Okay. All right. So, do you recognize what this is?
A solar panel.
That's right. So what I've done is I've taken a solar panel, and it has 2 leads on it. One's on the back side and one's on the front side. Mm-hmm. Okay. And I put them inside boxes with a hole in the front. And these are lasers. See the lasers, right? Mm-hmm. Okay. And now lasers are light. And light is what makes electricity. Mm-hmm. Okay. So these have, this box has one of these in the back side, but it's blocking all of this here. This is an amplifier, and it's plugged in to this. Now if I turn this on, there's a little bit of light coming in from these vibrating, these are actually vibrating lights. Fluorescent lights are vibrating so fast you hear a little hum. Mm-hmm. So if I take and I put, now the way a speaker works is it's got 2 magnets. It's got a metal bar with wire wrapped around it, mm-hmm. which is an electromagnet, and it's got a natural magnet on the back. And when you run electricity to it, it either attracts or opposes the metal bar, right?
Yeah.
Okay, because like poles oppose, and okay. So if I shoot light in here, it'll cause a pulse. Does it make sense?
Yeah.
Okay, so now okay, maybe you'd like to hold the laser. Hold the laser and point it at that hole. Okay, now I'm going to use my magic laser saw. You got a hypothesis what'll happen if I use this?
Yeah, it's gonna be very loud. It's gonna go.
You think it's going to be louder, or you think it'll be higher or lower? Louder?
It's gonna have more rings to it.
Okay, which would make it go?
Louder. Much louder.
And so it's higher, right?
Yeah.
Okay. Okay. So we're going to keep that fun up. We're going to do that fun. I got this propeller here. You're gonna have the same job. Okay. Okay. I'll shoot it in there. It doesn't turn on or off. So if two blades,
Sounds like a lawnmower.
if two blades make it that sound,
Imagine
okay.
3. It sounds like a lawnmower.
Okay. What do you think will happen with 3 blades?
It's gonna be much louder.
How about higher?
It's gonna be much higher. That's a very loud one.
Okay. Now let's try one more. This one's getting silly.
This one's gonna be so loud.
Well, it's got a lot of them, but how are we going to get them all in there? Okay, so if I turn it on, you're going to notice that there's 3. Okay, before we do this, we're going to do an experiment now. Okay, you notice that there's 3 circles? Mm-hmm. Okay, we start out with our hypothesis. What do you think it will be the inner circle? See the inner circle? Mm-hmm. What do you think it will be? Will you think it'll be higher, lower, medium? What do you think it'll be?
Lower.
You think it'll be lower? Okay.
Yeah, a bit lower.
Okay, let me try it. Let's see here. That's the hypothesis.
Much higher. Much
Okay.
higher.
You think it's higher? Well, wait a minute. Now there's the middle one. You think it'll be higher than that one or lower than that one?
Medium.
You think it'll be medium because it's in the middle? Okay. It was higher. You see that? It was higher. Now, what about the third one on the outside?
Higher.
Think it'll be even higher, okay? Because the first 2, yeah, okay, okay. It's the same. Why would it be the same?
I don't know.
The same number of dots. They're farther apart.
Oh.
So we can figure that out by rate. Every time it goes around is once around, right?
Yeah.
So
There
it's
you go.
cycles per second.
Nicely done, Dave, talking about rates, ratios, percents, probability, all of that great stuff. Excellent activities today. I'm sure Sophia learned a little bit. And thank you once again, Dave, from Buena Vista Museum for coming in. And we'll be back with more right after this.
Plants are amazing. They have this process called photosynthesis, where they take water and carbon dioxide and combine them to store the sun's energy in the form of sugar. And as an added byproduct, they even produce oxygen. Let's take a look at all those different parts. First up, water.
Water's pretty amazing stuff. It can be solid ice, it can be liquid water, or it can even evaporate into water vapor, which is invisible in the air, just like this. It can become clouds or fog, and then it can come down as rain or snow. You can find it in a swimming pool, or in a creek or a river, just like this one. You can find it in lakes, like here at Clear Lake, or in the estuary, like here at Morro Bay. And the saltwater oceans are teeming with life.
Next up, let's look at carbon dioxide. Here's a carbon dioxide cylinder for making soda.
So we can screw this into our soda stream machine here. It squirts it into the water and makes a nice fizzy drink for us.
Here's another way to make carbon dioxide using baking soda and vinegar, the same ingredients as that classic build your own volcano experiment. Let's see what happens when we mix them together. Here's some frozen carbon dioxide known as dry ice from the grocery store. Let's take a hammer and chip a piece off.
There we go. Water vapor in the air kind of condensing into clouds around it. It's very, very cold. Let's see. Here's our thermometer here. Let's see how cold it actually is. Minus 30, almost minus 32, 33 degrees, 34 degrees. Wow, that's pretty cold.
So we're going to seal some in a Ziploc bag, and you can see how it changes directly from a solid into a gas. It's called sublimation. Watch what happens when we pour out this cup of carbon dioxide. Next up, let's see if we can find evidence that energy comes from sunlight.
Here's an old solar-powered floodlight that I found, and what I thought we'd do is we'd take it apart and see what's going on inside here. So here's the solar panel right here that gets the energy from the sun. See, inside here we have a battery to store the electricity for when it's dark. It can come on in the dark. So let's pop that out. And what we're going to do is we're going to add some extra wires right here and here so we can connect it to some other stuff. Here's the other one. So here's my solar panel that I took off and borrowed for a minute.
Watch what happens when we clip these wires from the solar panel onto this little LED light. And then watch again as we cover and uncover the solar panel. The big solar panels you see on roofs are just lots of tiny little ones connected together. Alright, next up, let's look at how much energy is actually stored in the sugar. Here we have more complex sugars like the corn syrup in the marshmallow and the cellulose in the wood releasing their energy as they burn.
Here we have a coffee can with a candle and a pipe with some powdered sugar. Watch what happens when I blow down the other end of the pipe.
Lastly, let's talk a little bit about oxygen.
Because you can't see air, you have to look for other evidence that it's there. It wasn't until the late 1700s that a guy named Joseph Priestley discovered there was oxygen in air. Now let's take a look at what we now know air is made of. So we now know that it's about 78% nitrogen, it's about 21% oxygen, which is what we need, a little bit of argon, just less than 1%, and only about 400 parts per million, this little black line at the top, is carbon dioxide that plants can use for photosynthesis.
Never stop learning. That is exactly what we do all the time, and always with Camp Keep. Hey, you know what? We do have phone tutors available until 5:30, as we do most Tuesdays and Wednesdays throughout the regular school year. We have 5th grade student Sophia from Reagan Elementary. Has been there since kindergarten. You're doing some excellent work today. You ready for one more problem?
Yeah.
All right, let's take a look at it together. Beth wants the floor for treehouse to be 48 square feet. She wants the length to be 3/4 the width. Using the strategy guess, check, and revise, Beth guesses the dimensions will be 4 by 12. Is she correct?
So Sophia, we just want to make sure that this guess is a good guess. And there's two parts to it, right? One is the guess going to make the area correct? And the other one is the guess going to make the dimensions correct? So let's look at the area first, okay? She guessed 4 feet by 12 feet. If those were the real dimensions of the room, would that give you an area of 48 square feet?
Yes.
It would. So the guess is correct as far as the area, right? That's a pretty good guess. Let's see if it meets the other criteria, okay? She says over here that we would like the length to be to equal 3/4 of the width, right?
12
So
is
3/4 of the bigger one. 3/4. What does that word of mean?
multiplication.
That's right. 3/4 of 12. We don't actually have to do the work, but think about it.
Yeah.
Is 3/4 of 12 going to be 4?
Yeah.
You think so?
Yeah.
Think about this. Is 3/4 above a half or below a half?
Above.
It's above. Okay. What's half of 12?
Half of 12 is 6.
Is 6. So the answer should be above 6, right?
6. Yeah.
Is 4 above 6?
No.
So it's not quite right. We don't have to know the exact answer, but this is another wonderful example of it meets the first criteria, but the second one, we may not know the exact answer, but the guess is not going to quite be right. So her logic that she went through isn't going to quite work because you know it should be bigger than 4. In fact, it should be bigger than
6.
6, that's right.
Because
Of course, if you made it bigger than 6, we'd have to go back and figure out the area part too.
Yeah.
But at least we know the guess isn't quite right. We'd have to check and revise, right, and go back and check it again. So
There you
there's
go.
more work to be
Nice
done on that
work
one.
doing that.
Yep.
All right, nicely done. Well, you know what's coming up very soon? The Mars rover Perseverance touches down on the surface of Mars this Thursday around noon our time. The mission in part is to gather Martian soil that may reveal clues about the red planet's past, specifically if there has ever been life on Mars. We've been looking ahead to the special STEAM event with behind-the-scene peeks at how this mission has come together and what we can expect to see once Perseverance lands on Mars.
Sometimes you have to do something just to show that you can do it. When the Wright brothers flew for the first time, they flew an experimental aircraft. And in the same way, the Mars helicopter is designed to show that we can fly powered helicopter flight in the Martian atmosphere.
From day one, this was the unwavering dream of our team, to get our helicopter launched to Mars so that we can get that opportunity to do that very first rotorcraft flight test in the actual environment of Mars. It's extremely difficult to fly at Mars because the atmosphere is so thin. Compared to Earth, at Mars it's less than 1%. So the first and foremost challenge is to make a vehicle that's light enough to be lifted. And then the second is to generate lift. The rotor system is to spin very fast. 2,000, 2,200, 2,400, 2,600. We're spinning between 2,000 and 3,000 revolutions per minute, and it takes a lot of energy. So it's that balance of a very light system, yet having enough energy that's needed to spin the rotor so fast to lift, and on top of it, having to design in the autonomy.
It has to be fully autonomous from the time it takes off to the time it lands. What we do on the ground is we plan the flights, and so we determine from here where we want the helicopter to go.
Our experiment window is 30 Martian days. So we have planned up to 5 flights of incremental difficulty.
The very first flight, the main thing is we want to get the legs off the ground, and so we will basically go up about 3 meters, and we'll hover there, and then we'll come down again, and that will be the first, really major milestone.
Most of our flights will be at the 3 to 5 meter height. We will be going horizontally again at a few meters per second, probably go out, 50, 70 meters and come back. In successive flights, we'll probably push that further, try to go further. So our priority will be to get back engineering telemetry and not so much images, but I'm sure we'll return a few, because they'll always look cool.
At this point, we've tested all we can on Earth. We have mathematical models that shows how it'll fly at Mars, and we've tested it in the simulated environment that we can create on Earth. It really is time now to do the real flight test at Mars.
Nothing is a given, but we have done everything we can in terms of a test program here on Earth. The vehicle's performing extremely well so far. It's been doing exactly the right thing, even right now when it's bolted onto the Perseverance rover. So there's a very good chance that we'll pull it off, yes. But it's still high risk, and none of us forget that you could have a glitch that, could mean end of mission, yes.
It's going to be exciting, reacting to any surprises we have. We can't wait. What's really most important is everything we're learning here is for the future rotorcraft systems that we want to introduce into space exploration.
Perseverance touches down on the Martian surface Thursday around noon. Live coverage begins at 11:15 a.m. right here on KETN, streamed via our Facebook page and, of course, online at dothemathonline.net. And exciting stuff coming up on Thursday. Perseverance touches down. Sophia, are you ready?
Yes.
All right, let's take a look at these clues. Read the first one for me.
There is a red piece right in the middle of on the bottom of Terry's triangle.
Okay, so we know there's a red piece right in the middle on the bottom. So where would you like to put one of these?
Like right here.
Okay. So were you going to go down or are you going to go across? So which one do you want to do
I'm
next?
going to go here.
Okay.
There are twice as many blue pieces as green ones and half as many reds as blues.
Okay, so it says there's twice as many blue as green. So how many blue and green are there?
2 greens, twice as many, so it's 4 blues.
And do we have 4 blues that we can use? And then it says half as many reds as blues. Do we have half as many red as blue?
Yeah.
All right.
Okay.
So we know all of our pieces are there. So
Yeah.
we're basically done with that.
Okay.
We're still going to use the red in the middle on the bottom. So what's next?
Each blue piece touches another blue piece.
Okay. Now remember, we're making a triangle out of this whole thing.
Triangle.
Right?
Something
So
around
all
like
of these pieces are going to make a triangle.
I don't even know.
Okay, well, take a look at the other clues.
Okay. The red and green pieces form 2 identical small triangles that are parts of Terry's triangle.
Okay, so the red and
So
green
the red and green
pieces,
pieces form 2 identical small triangles.
so the red and the green are all going to make a triangle together. So how can you put the red and green together to make a triangle? Almost. Well, it's not quite a triangle, is it?
No.
What about if you put the other red on the top of it or something? Yeah, keep moving pieces around.
That's not a triangle.
You got a quadrilateral there.
Oh wait, it's kind of 2 triangles. Right there.
Well, keep working. What have you got next?
There, I have the 2 triangles.
Everything's got to be touching there, wise guy. Let's keep going, though.
Haha.
Aha.
The green piece that's right at the top of Terry's triangle doesn't touch the other green piece,
All right, so we know there's a green piece at the top,
which is this one.
and it doesn't, so there's a green piece at the top. All right, so think about we're going to make a triangle, all right? All these things are going to come down. We know there's a red one in the middle down at the bottom. The green doesn't touch any other green. So what you want to do is you want to use all these pieces and see if you can make a large triangle. See if you can make a triangle out of all those.
Okay.
And remember, green is at the top. It's all by itself at the top.
Yeah.
So there won't be anything above it.
Oh,
Okay, so if this is
green
the
is
top, those will be below it. And you know what? Did you learn a little bit of stuff today?
Yeah.
Did you have some fun today?
Yeah.
Well, I'm sure you did, and we're going to let you continue to work on that. And remember, we do have phone tutors until 5:30, and until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.